full of vitamin A. All right, so.
You guys know make homemade chili? I mean, like chili sauce?
Yes. All right, ready? So this is completely related to everything we've done. Though you might not see how it relates right away. I don't think graphing trig functions is difficult because I was able to figure it out when I was, 29 years old and teaching. I'm just kidding. It is not a tough concept as long as you remember basically your unit circle, and you kind of proved it yesterday that you know the unit circle. Now here's the great thing about the unit circle. I'm not too worried about the 30 degree or the 45 degree or the 60 degree angle on the unit circle as you go around it. I'm more concerned of where does it cross the x-axis, where does it cross the y-axis. So it's either at 1, 0, negative 1, 0, 0, 1, or 0, negative 1. That's all I'm concerned about. Okay, so what we wanted to think about is if I have my unit circle, and let's just pretend I can draw a really good circle. So this is at 0, and this is also at 2 pi. This is over here at pi. So the point here is I have 1, 0, and I have negative 1, 0 on the x-axis. Agreed? Yeah. On the y-axis, I have pi halves and 3 pi over 2. And those are the 2 points of 0, 1 and 0, negative 1. Anybody stuck on any of that?
No, we're good.
There you go, and there you go. I thought you guys would bring ice cream at least.
Go ahead.
All right. Whoopsie. Let's see there. All right. All right. So we good? Feel good with those points? Anyone lost? Anyone upset? Can I move on? Okay. So just please note this. We are going to focus on those values. When we graph, I'm sorry to tell you this, but they really like it when the x-axis is in radians. Okay? And I don't think you're too upset about that and too distant, but what we're going to do now, the next slide, you guys are okay with the xy axis, yes?
Yeah.
Now, I know you've had this in your science class where maybe you make your labels and you scale it. Like if you're talking about gallons of water and you're talking about thousands of gallons, maybe on the y-axis you scale it at 100, 200, 300 for each mark. Or on the x-axis, maybe you scale it different. Well, what we're going to do is we're going to scale our x-axis, and we're not going to have each of our lines be at 1, 2, 3, 4. We're going to do it as, we're going to do it as in units of pi. Okay? So this is just my xy axis. Now, the sine curve goes forever to the left, and it goes forever to the right. Good with that so far? So ready? On our unit circle, sine is x or y? Y. Everyone's okay with that? So think about at 0, this is the point 1, 0. This is the point 0, 1. This is the point negative 1, 0. This is the point 0, negative 1. And this is the point 1, 0. It comes back full circle onto itself. Okay, I can keep going around the unit circle an infinite amount of times no matter what. But watch how simple this is. At 0 pi, which is 0, my y value is 0. No, when we deal with cosine, it's 1. But see why I said 1. All right, so most part, the standard function is going to go between positive and negative 1 in the y direction. All right, so at pi over 2, or half pi, what is my sine value?
1.
Oh, okay. So here, at that point. At pi, what is my y value? We made it perfect.
Thank you.
0, which is there. At 3 pi over 2, what is my sine amount?
-1.
Oh, okay. And at 2 pi, what is my sine amount?
0.
That's it right there. That's your sine curve. It keeps going. So how do you get to the negative values? You go around the unit circle clockwise, getting the negative angles. How does it keep going? You keep going around the circle. That's what your basic parent function sine curve looks like. It has maximums, it has minimums, it crosses the x-axis. Yay. Any questions on that so far? Good in the hood? All right, can I move on?
Yep.
All right. Okay, so we're going to take a look at this one. So we're going to talk about the midline. The midline is the line in which it goes an equal amount above and an equal amount below. So with that kind of definition, what does it appear my midline is? Does it appear my midline is the x-axis, or did it move up, or did it move down? So my midline is 0, so it's my x-axis. Is that okay? Okay, now the amplitude is how tall, or how tall above or how far below my midline does my graph go? Just by looking at it, what do you think?
2.
It goes 2. Cool. And then the period. The period is how often does this happen? Does it start repeating itself at like pi over 3? Or does it start itself back up between 0 and 2 pi?
What?
So just so I label it, pi over 2, pi, 3 pi over 2, 2 pi.
Oh, it starts repeating itself at 3 pi over 2. Pi over 2.
So it starts here. So start here is the thing. I'm just showing you more. I see what you're saying. You're absolutely right. Yeah, I would start here and restart here. But if we start right at 0, 0,
Okay.
use the origin as, and I didn't tell you that, so I apologize. So it starts here and it starts repeating here.
Okay.
Agree? Yeah, so I can pick any two portions, but try and start it based on the origin. That would be your best thing.
Okay.
So
That's where they're both going up.
yeah, so it, like if I started here, it's on its way up. Started here, it's on its way up. Exactly.
Nice.
Okay? So the period goes between 0 and 2 pi. Okay? And for the most part, you're going to try and keep it at 0 to do that. So let's deal with our equation. Well, I know it's a sine curve, so I know I got y equals sine x. Okay? What stretches things in the vertical direction? It's like an a value, right?
Mm-hmm.
So that's that. And we're done. Okay? So y equals a sine of x, or theta. This talks about the amplitude. It's how tall it goes. Okay, and usually the amplitude is the absolute value of that. So if you had a graph upside down, the amplitude's still a distance. But if I have a negative value as that 2, it just flips the graph over. So it does one of these. These zeros stay here, and these go like this. Okay, this would come down here, this would come up here. Okay, so the amplitude is usually a positive value. Any questions so far about this? Now, just so you know, this will indeed, as you build upon this, so this is kind of where we're trying to head. This gets a little shady later math classes like a year from now. Okay? When I say a little shady, not in a bad way, it's just that the graph itself, this graph will do everything that all the other graphs will do. It can stretch in the vertical direction, it can compress in the vertical direction, that's the amplitude. It can shift left or right, which is basically in that grouping part. It can shift up or down, and it can flip upside down, or it can flip over the y-axis. Yeah.
Did we win last night in basketball?
No, but girls put a whooping on them.
Who did they play?
Grandview.
Jana put a whooping. No.
Yeah, I think she had 36.
Dang.
33?
That's
Yeah, it was a good win. Good win for the girls. Boys, I think, lost by 11, I think.
okay. It's because we weren't there.
I know. I kept looking over. Your section was blank. There was like, 4 kids there.
Yeah, well,
And Grandview had like 600 kids there last night. I'm just kidding.
dang.
They had nobody there. Go this week, though. Friday. Rapo.
What time?
Stinking Rapo. Well, what time do you think?
7.
Yeah, there you go. Come to the girls' game, too.
I'll be at the
I have
Arab
a-
game.
You have a what?
Can't.
Dude, screwed.
I'm playing.
Friday at Creek at 7.
Friday, Creek, 7.
I'm playing to catch.
We
Where-
already played Arab.
How about Wednesday?
We already played Arab.
I know, but that's our last home game of the season, so it should be fun.
How about Wednesday?
Wednesday, nothing. We got a pretty easy week,
Dang.
which I'm thankful for because I was here till 9:30 last night. So
Is Creek even in the playoffs?
they'll make our brackets after Sunday night.
Alright. We'll go to those games in Heckle.
No, you're not.
Yeah, we will.
I go to pretty much every game. I just want to let you know that.
I'll go to the.
I know. I missed you guys though. I was like totally looking out for.
Tell Dean
Come on,
Weber to
Friday.
back off.
Huh?
Yeah, tell Dean Weber to just.
Back
Yeah,
off.
for playoffs, they gotta let
Tell
us
him to
just
back
say
off.
what
We
we
need
want.
to heckle.
I'm sorry, but we have to heckle.
We have to heckle.
The
He's
games
such
we
a
win is when we
softie.
get in their head.
Yeah.
I know. Okay.
Mr. Sturb, you know. You know.
You
dude.
gotta
We need to
talk,
get in their
yeah.
heads. Otherwise,
This is why we lose.
I'm a chirp Joe Liberty.
Okay.
You know what? I don't even care. I'm just gonna start going on.
Yeah, he sits.
Get the rhinestone cowboy back there.
Gonna
Gonna start throwing chairs.
Weber can have to deal with me.
All right.
Yeah, I'll just take the in-house.
So
That's what he should.
I'm not a huge fan of this one, but I think we can do it. I think we can slate through it. So does this?
I don't know.
So first, let's go through the things we know. What is my midline on this?
0.
0. How high above or below the midline do I go?
1.
Okay?
This is where I don't.
And this is where things kind of pause for a second. So let's take a look. So could I classify this as my starting point?
Yeah.
Could I classify that as when it would start repeating? Okay, so now I need to go and try and figure out what my exact period is going to be. It's going to go from 0. It's going to go from 0 to here. But where exactly is here? Well, let's be cautious. So I have pi halves here. So that would mean that this has to be that halfway distance, right? So how do I do half of a fraction? Say pi fourths. You double the denominator. Is that okay? So I'm just trying to figure out what my values are. And then if I take half of, so if I take half of that, this is going to be pi over 8 right here. So then I need to figure out kind of where this one is. And I'm just trying to gauge it so I'm seeing a pattern. So 0, pi 8, and then this is 2 pi over 8. So then this should be 3 pi over 8. Is that okay? And this is 4 pi over 8, which reduces to pi over 2. So this point here has to be at 5 pi over 8. Now this is a little harder to start fathoming, but think about it. If I get my common denominator being 8s, this is where I would have had, what'd I do?
What's fathoming, honestly?
I don't know, sounded like a neat word to use. I saw it on the word of the day. I didn't read the definition, it's too early.
I don't know what it is.
Okay. So that point right there is actually 2 pi over 8. This point, that value right there is actually 4 pi over 8. Okay, does everyone agree with how I've counted that? So this is the reduced version of 2 pi over 8. This is a reduced version of 4 pi over 8. So now we have 5 pi over 8. So we have to figure out what's taking place with this. Is this graph happening more often?
Yeah.
Yes.
Okay, so there's something in our equation. I know I agree with this so far. But then there's something here that's taking place. Is that okay? So, I'm not a big fan of this problem because there's a bigger step that we have to realize, and then as soon as we get done with this step, we're actually going back to much easier. Okay, so I'm going to convert this to bx plus c right there.
Wow.
Okay, so if I distributed b back over the parentheses, that becomes bx plus bc, right? Algebraically. But the thing is, I don't have a shift at all in my thing. Like my graph didn't move left or right. Okay? So I think I can call that then 0. So then that becomes bx. Okay? And I'm trying to get you to see a point here that you're going to see more of this next year, but now we're going to kind of resolve back to just having this bx. So now we have to say, okay, what would I do to make my graph repeat every 5 pi over 8? Usually it repeats every 2 pi. So let's see if we can. So this is repeating at 5 pi over 8. It normally repeats every 2 pi. Okay? So let's do this. This doesn't make sense because we don't have an unknown. So what I'm going to do is I want to figure out what x is. Now, or let me change that not to x. I'm going to change this to, we're going to change it to P for Peyton. Okay?
I like to hear.
All right.
Admitted.
So let me ask you this: How would I go from? How would I get P all by itself? Divide by 2 pi. Does everyone feel good about that? So if I divide by 2, I get 5 over 16. Okay, so I divide, and that's gone. So now I get P equals 5/16. Is that okay? If I divide by pi, the pi's cancel. If I divide by 2, I double the denominator. Is this what I want to do with this problem? I'm trying to think if I want to do this. You know what I'm going to do? We're going to skip this one because I know I'm not going to make you do one this complex. It's something you're going to see next year, and you'll actually, when you're working with these, pre-calc. Good. The one that you're not taking. All right. So let's get back to stirrup easier.
I have
Yeah.
a question. Is college trig a high class this year?
Yeah, it's hard.
Idiot.
But you'll get through it.
What's the hardest class?
This one.
I feel like I might have changed it though.
I hope you do.
Really?
I think this is the hardest math class that you will ever take.
Are you
No
teaching?
way.
Really?
I am dead serious.
Are you
Like
teaching
AP
college?
You think this is
algebra?
harder
This-
than
Yes.
This is
Pre-calc?
harder than
Yes.
calculus?
Yes.
How's it what?
This is the most difficult math class, in my opinion, that you would ever take.
why?
Pre-calc AB.
This is the same as last year, except for like.
Calc AB.
Are you repeating this class?
No, freshman year, sorry.
You're repeating it from
This
your
is
freshman
not
year?
the same as freshman
Boy, you were
It's like
smart
the
as
same
freshman.
Algebra 1.
Oh, it's
But
not.
semester one is the same.
It's like the same as Algebra 1, but I'm bad at it this time.
Alright.
Yeah,
Are you
that's a
teaching
good way to
college
put it,
algebra?
Sam.
No, my degree isn't, well, I have a high enough degree in order to teach the college level.
He took you for college algebra.
Do what?
John said he took you for
He
college.
did, but he didn't get college credit for me because, so we offer CU credit. I have satisfied all the requirements for the CU credit, but the person who runs the CU program hates me and will never qualify me.
Why do they hate you? What'd you do?
What
to them?
about?
Well,
stats and
I used to teach with him at
probability?
Chaparral, and he hated the fact that my students liked me, and so he made up these vicious rumors saying that I was just giving students A's. And when Ron Peterson, the principal of Chaparral, ran a report to say, "Gosh, is Chris Durb giving all A's?" I get a note in my mailbox saying, "Please see me." And of course, I'm just like any kid. I see the principal needs to see me. I did something wrong, and so I walk in and I say, "Hey, Ron, what's going on?" He goes, "So there's a complaint from your department from a couple of teachers that say you give all A's." I said, "Well, Ron, that's not true." He goes, "Oh, I know it's not true. First off, I ran a report of your grades against your math department. And then I ran a report of your grades against the rest of the school." And I'm thinking, I'm getting that sinking feeling going, oh no. I said, "Okay, what'd you find?" He goes, "You have more F's that come out of your class than any other teacher on this campus." And I said, "I do?" He said, "Yeah." And he goes, "But Chris," because that's my name.
Your name is Chris?
Yeah. He goes, "But Chris, you have the least complaints of any teacher on this campus." And the guy who runs the CU Gold program at CU Denver now, who I taught with at Chaparral, when he heard that, he was so angry. He was so angry because how can this guy have kids coming in, they adore him, they love him, they request him like crazy, and then he's got more F's than anybody else? So when I was about 10 years ago, they said, CU said, "Hey, you need to have at least 18 credit hours in graduate level math." Oh, okay. Well, I had 24 credit hours in graduate level math. So I applied, and I got this letter that said, "We're sorry, you're not a good fit for our program." And so then I challenged them. I said, "Well, why am I not a good fit?" They're like, "Oh, you just don't satisfy it." And I said, "Well, I have a degree in math, and I have these hours that you say I need to have." "Well, yeah. You understand there's people that are at Chaparral High School who have a minor degree in math, meaning they took Calc 1, Calc 2, Calc 3 differential equations, and that was it. And they're teaching your classes, but me, who has a degree in the class, in math, as well as 7 courses that are graduate level math courses, but I don't qualify." So all of a sudden they did this to all the people with a minor in math. They yanked them out and said, "You're not qualified." So, but Joe Bolello is the guy's name. He will not. He
Where does
will
he live?
not.
He's exposing him.
Where does he live?
Right by Heritage High
All
School.
right, we'll egg him.
He will not ever qualify me to teach CU Gold.
Well, I'll protest. We'll start protests at his house.
Well, he's now kind of has some other teachers in here who have a much higher degree than me. They have masters in math, and he's not qualifying them to teach. So he's like this agenda against me. He hates me. And this is what's so funny. He hates me, and he really dislikes my wife. But he doesn't dislike my wife because my wife's done anything wrong. But she has a much higher degree than he will ever have, and he can't stand her.
We'll just
What does she have?
PhD in accounting.
And she's hotter than his wife.
Clay.
He's jealous.
Clay's checking out the wives. All right. Oh, I'm squeaking. Sorry. Back to math.
We'll piss on his lawn. We'll find out where he lives.
All right. Has my midline shifted on this one?
Yes.
What does it look like my midline would be if you had to take it?
-3.
-3, okay. So now let me ask you this. How high above and how far below my midline am I going to go?
Just one.
Yeah, I go one above it and one below it. So my amplitude's still 1. Does that seem okay? So again, we're calling this our new midline. So I went 1 above it and 1 below it. that make sense? It appears that it starts here and it repeats here. So what does it appear my period is? Goes from 0 to 2 pi. Does that seem okay? All right, so see if you can guess why my equation is this. 1 sine x minus 3, which then actually should be written like this because you don't need a 1 out front. Why does that take place?
Because it's down 3.
Yeah, that minus 3, just like in all your other things of shifting your math around, that one will, that's why it takes place. So that negative 3 is not grouped, it's just added or subtracted to the outside. Cool? Seem okay? All right so far? Can I move on? All right. So midline is 0. Okay. Amplitude, how far above? 2. Goes from 0 to 2 pi. Agree? Anyone want to take a shot at what this equation is?
Y equals 2 sine.
There you go. Y equals 2 sine x. Done. That 2 out front just makes it go that much higher or lower below the midline.
So it's not like pattern graphing where you multiply it all. It's just
Nope,
like.
because it's doing this. It's not continuing to grow. It's just.
Oh, nice, cool.
All right. I think you guys are ready for this part. You ready for this? What? What don't you understand? Okay. Question. What's the reciprocal of sine? Cosecant.
Cosecant.
So if I wanted to graph y equals 2 cosecant of x, you with me?
Oh, you flip it.
Ready? Ready? Okay. Because I can't have 0 as a denominator, these points don't exist on our graph, so we actually create an asymptote. These are vertical asymptotes. Okay? Still with me? And then, this point becomes this point, and this goes down like this, and this point goes up like this. That should join a point right there. But the black is what a cosecant graph looks like, and it keeps repeating. Where your cosecant graph, you have a restricted range. Because your range doesn't happen in there. Okay, but you don't really need to know that, so that's added bonus, added stirrup bonus stuff.
Just to stir up the pot.
Stirring it up, All right. Midline. 1. How high above and below the midline am I going? 1. Yeah, 1. So from there to there's 1. From there to there's 1. Okay, so cool. Okay, so this is going down here. It's going down. But then it starts repeating here. So it appears my period still. So if I'm going down and then going down, it's repeating every 2 pi. So from 0 to 2 pi is where my period's going to be. All right, so now, here's my midline. Normally, my graph is doing this. Kind of like that, right? So what would cause this to flip down? Negative where? Yeah, it's right here. Okay. Oh, and this had a different midline, so I need to go plus 1. Okay, so the negative means it flips over the midline, and then the plus 1 is because it shifted up 1. Can I move on? Almost done? Oh! All right, now let's try graphing it. All right, what's my midline? 3. So I'm going to call this y equals 3. So then I have 2 here. I have 1 here. I got 0 down here. I got 4. I got 5. So this is really my x-axis, right? Okay? And here we go. Here's 0. Here's pi halves. Here's pi. Here's 3 pi over 2. Here's 2 pi. So this one just shifted up 3, correct? So I changed my midline. Okay? So my axis is actually down here. But here we go. So here, 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 here. Done.
Nice.
So I changed my labels on my axis to allow me to graph it. I didn't go and try and squeeze up 3 on this. I hope I did it right. Change my labels. So all really I know how to graph is the sine graph. And then change your labels.
You don't have to.
Okay? And I'm going to show you how to change your labels on the x here in a second. Can I move on? Yay. All right. -2 sine. This doesn't shift up or down at all, right? How high above the midline do I go? So we get 2 and -2. Okay? So that's 0. It's pi halves. It's pi. It's 3 pi over 2. That's 2 pi. So we're going to go here, then to a min, back to a 0, back to a max, back to a 0. There it is. What's my midline? 0. What's my amplitude? The absolute value of that is 2. What's the period? It goes from 0 to 2 pi. Done.
This is easy.
So we don't have to remember like any of the other stuff on the unit circle besides like.
Well, no, it's very important to continue to go back, be able to do that. But we're only focusing on, because here's the thing. Pi fourths was 45 degrees. Right?
Yeah.
So it all still exists on there. It's just I'm not utilizing it.
Okay, cool.
How often is this one happening? It's going to happen more often.
Yeah.
Watch this. Ready? So it's going to go up to 1, go down to -1. Still with me? So I have pi halves. That's 0. Pi halves. Pi over, or excuse me, I goofed. It should be pi. 3 pi over 2 and 2 pi. Agree? All right. This means it's going to happen 3 times in here. But there's no way I'm going to say, hey, let's try and artistically show this happens 3 times in here. Got it? So watch what I'm going to do. Put your pencils down. Watch. This is what my normal function looks like. Agreed? Everyone agree with this? Okay. And so it's going to happen 3 times in there? Okay. Well, I'm going to divide this by 3. So 0 divided by 3 is still 0. I'm going to divide this by 3. So that's going to give me pi over 6. I'm going to divide this by 3. It's pi over 3. Divide this by 3, which is going to be 3 pi over 6, which is, so that's 3 pi over 6, which reduces to pi over 2. And I'm going to divide that, so that's 2 pi over 3.
Nice.
Okay, so now I'm not worried about these, because that's the new labels.
So you just label it different?
Yeah, because it happened 3 times. Okay, so if this was a 1/3 pi, that means that only 1/3 of it's going to happen. So you'd multiply each of these by 3. So if that was, if we wanted to draw y equals sine 1/3 x, or 1/3 theta, I would have this happening at 0. This would be at 3 pi over 2, 3 pi, 9 pi over 2, and 6 pi. Okay? We're not going to worry about it. Notice I just graphed sine, and I changed my labels. All right. This, when it's grouped, means it will shift right by pi over 2. Shift right by pi over 2. Shift right by pi over 2. Ready? The midline here is still going to be 0. The amplitude is still going to be 1. Ready?
Yeah.
So 0, pi over 2. Pi. 3 pi over 2. 2 pi. Still with me? Okay. Friends, listen real quick. I still have you for a couple minutes. If I shift right pi over 2. If I shift right pi over 2.
Oh, you can add just pi over 2.
Good. I add pi over 2 to this. So this becomes pi over 2. Still with me? If I add pi over 2 plus pi over 2, I get 2 pi over 2, which is pi. Pi plus pi over 2, that's 2 pi over 2 plus pi over 2 is 3 pi over 2. Pi over 2 plus 3 pi over 2 is 4 pi over 2, which is 2 pi. 2 pi plus pi over 2 is 4 pi over 2. So that's 5 pi over 2.
Also, I mean, couldn't you just like look at it and be like shifted?
Sure, if you want to work that hard. So what is this now still the y-axis? Is this still the y-axis? No. What is that? It's pi over 2. So the y-axis is actually here now. So I changed my label. I realized if I have a shift right, that means add pi over 2 to all of my points that I already know. If I subtracted, if this was a plus, I would subtract it. That's all you have to do. One last slide. Okay, and I'm not going to run through all of this. Let's see, I got to go here. Go here.
How do you Minecraft?
I don't know, because there's preloaded stuff on these computers. Okay. So, TI tools. There we go. All right, let's pull up this graphic calculator. Thought it's coming up. There it is. All right. So the very last slide has you putting in months. So January 1, February 2, March, so on and so forth. Okay. So this is all you would do. I don't need to go through all of this, but ready? This is how it works. Ready? All right. So, oh, cool. Look at that. So once you plug your stat plots in, remember under calculate we have linear regression, or if it's a line, quadratic if it's a parabola, cubic if it's third degree, quartic if it's fourth degree, and then natural log regression. Well, if you go down this graph, natural log regression, exponential, power regression, logistics, look what that says. Guess what a sine regression will give you? Yeah, so if you plot your dots,
Thank you, Drew.
once you plot your dots, my friends, once you plot your dots, you put them in there, go on your stat plot. So homework is, what is it? G? Hey, worksheet G? No, you can do the whole thing. Hey, a couple of you still need to make up a quiz with me, yes? Can we do that by Friday?